All right. Hopefully you feel pretty well practiced. I mean, these are basic formulas. When you think about arc length, you're just going, man, arc length. And I got to tell you, I mess these up because since arc length is abbreviated S, I always want to call that sector area. But arc length is just radius times theta, and sector area is 1/2 radius squared times theta. And again, both cases, that theta has got to be in radians. All right, so these were pretty simple problems. You had 6 easy ones. I just wanted you to kind of get a little bit of practice feeling good about these. So here's the answers. For number 5, the arc length is 2 pi and the area is 12 pi. For number 6, the arc length is 4 pi and the area is 24 pi. For number 7, the arc length is 4 pi over 3 and the area is 8 pi over 3. For number 8, the arc length is 2 pi over 3, and the area is 4 pi over 3. For number 9, the arc length is 40 pi over 3, and the area is 200 pi over 3. And lastly, for number 10, the area is 35 pi, the arc length is 35 pi over 4, and the area is 175 pi over 8. All right. Okay, so this should be a pretty simple thing and not too bad. So what I want to do is now I want to try a couple application problems. Okay, what I'd like you to do is right beneath those problems that you just worked, what I want you to do is I want you to continue on page 146, and I want you to try 11, 13, and 15. 11, 13, and 15 are all real world style problems. One deals with the tip of a minute hand on a clock, one deals with a space shuttle flying over the earth, and one deals with the pendulum of a grandfather clock. So pretty simple. So try these 3 problems. I'm guessing it's going to take you probably about 5 to 8 minutes, and then we'll go through them real quick on this video. So we can pause the video right here, and then we'll talk about those. Okay, so let's talk about this. Number 11, the key details is that we're talking about the minute hand of a clock, and the minute hand is 2.4 centimeters long. And it says, how far does the hand travel in 20 minutes? Now, this is the part that if people were struggling, I think some people were struggling with the idea of what is 20 minutes? Well, 20 minutes is to here. You know, that's where the 4 is, all right? And so you can think about it a couple different ways. One of the ways I think about it is I go, well, 20 is how much out of 60, and it's 1/3, okay? And I need a theta, and so I think, well, the all the way around is 2 pi, so I want 2 pi, but I need to break that into thirds, so it'd be 2 pi over 3. So that's what the theta is right here. Theta would be 2 pi over 3. There's different ways, or you may have said, 360 divided by 3 is 120, and 120 is 2 pi over 3. I don't know how you best wanted to do this, but I think that this problem was doable. Okay, so therefore, the arc length is equal to radius times theta, which is going to be 2.4 times 2 pi over 3. And at this point, I'm going to plug that into a calculator and say 2.4 times 2 pi 3. And I get that the tip of that hand traveled about 5.0 centimeters. Okay? Next, number 13. Okay, and number 13, it says the space shuttle is 200 miles above the Earth. And it shows a picture. I'm not going to take the time to draw it. But the radius in this situation is 4,200 because we got to account for the 4,000 mile radius of the Earth and then the extra 200 miles. Now it says it takes it about, 6 hours to go all the way around the Earth. How far does it travel in 1 hour? Well, again, I want you to think about it. We go, well, 2 pi is all the way around, so that would be 6 hours. So in 1 hour, it's going to be 1/6 of that. So 2 pi over 6 is going to be pi over 3. And that is my theta. Okay? Pretty simple. Arc length is equal to radius times theta. Radius happens to be 4,200 miles. And theta is pi over 3. So we get, 4,200 divided by 3 is what? 1,400. So we get 1,400 pi miles. Now that's a pretty terrible answer because that doesn't make a whole lot of sense. But even in the problem, it says, give the exact value. Well, that is the exact value. And then it says, approximate to 3 significant figures. And if we're going to 3 sig figs, which was really kind of dumb for the book to say because 3 sig figs actually rounds to the same as 2 sig figs, which is 4,400 miles. So in 1 hour, the space shuttle travels about 4,400 miles. And so if you didn't catch that, that would be 4,400 miles per hour. That's pretty crazy. Now, I don't know if this problem is based off of reality or if they're just making up numbers, but that's pretty incredible. Okay, and lastly, let's talk about number 15. Okay, so 15 is the grandfather clock that has a pendulum that's 4 feet long, and it says it's swinging through an angle of, 20 degrees. Okay, so the first thing we got to do is go, well, theta is 20 degrees. That's not on the unit circle, so I'm going to multiply that by pi times 180, which gives me 20 pi over 180, which reduces to pi over 9. Pretty nice. Arc length is equal to radius times theta. Radius is 4. Theta is pi over 9. Okay? And so that's going to be 4 pi over 9. And that would be the exact value. And then if I want to find the approximate value, let's see here. How far did it travel in 1 second? Well, it traveled about 1.4 feet. Well, that's pretty impressive. Every second, it swings back and forth, 1.4 feet. All right, hopefully these 3 made some sense. What I'd like you to do is I want you to try 2 other ones, okay? So what we're going to do is we're going to look at the next page, and I want you to try number 21 and 27, okay? 21 has to do with the diameter of the moon. So we're looking at the next page, page 147. I want you to try 21, and I want you to try 27. 27 has to do with the Ferris wheel. 21 has to do with the diameter of the moon. Both of them have to deal with arc length. So go ahead and give those 2 a try, and in about 10 minutes, we can start up this video again. So we can pause it right now. Okay, hopefully you feel pretty good about these. It does use that word subtends. It says the angle from the Earth, the angle that the moon subtends is about 0.5 degrees. Okay, so this is number 21, just so we know. And what we do know is that the distance to the moon, which in this case would be the radius, is about 240,000 miles. Okay. Well, now the first thing we got to do is we got to go, okay, I got to convert the 0.5 to radians. So I got to put that pi over 180, which gives me 0.5 pi over 180, which is the same thing as pi over 360. Okay. And so the arc length, which is going to be kind of equivalent to the diameter of the moon in this situation, is going to be equal to pi over 360 times 240,000 miles. And so I plugged that into a calculator because at this point, I mean, that's going to talk about an exact answer is pretty ugly. So it says what? Find it to the nearest 100 miles. And so you go, okay, so pi divided by 360 times 240,000 miles. And that gives me about, what do you get? If you round it to the nearest 100 miles, I get about 2,100 miles. Okay? Did I do everything right? That seems off, but no, that's right. Yeah, that's right. 2,100 miles. Okay. And so it's amazing when you think about the diameter of the Earth being about 8,000 miles. I always thought the moon was so much smaller, but this is not. This is only about a fourth of the size in terms of diameter, and so that's wild. I would have thought the moon was like a tenth of the size or something. So it's interesting. Okay, number 27. They do a Ferris wheel. Okay, we love those Ferris wheel problems, and so they're basically looking at this idea of this Ferris wheel and saying, hey, you start here and you're traveling around. And we're just saying, how far did you travel based on what this angle is, and we're going to call that theta, and theta is 60 degrees, and theta is what, 210 and 285. Okay, the nice thing is that 60 and 210 are on the unit circle. This is pi over 3, 210 is 7 pi over 6, 285 we've got to convert. And so that's going to become, that's going to be what, 285 pi over 180. Let's see, what goes into both of those? 15 goes into both of those. And so this is 19 pi over 12. Well, there you have it. Okay, now it says in this situation that the diameter of the wheel is about 197 feet, which would make the radius 98.5. And so we can just kind of work through this. We go, okay, so it's going to be 98.5 times pi over 3 for the 60 degrees, which ends up being 98.5 times pi over 3, gives me about 103 feet. Okay. And then we think about 98.5 times 7 pi over 6. 98.5 times 7 pi over 6. And for that one we get, well, it's about 360 or 361 feet. That's a pretty long trip. And then lastly, for the 285 degrees, we'd go, well, that's going to be 98.5 times what? 19 pi over 12. So you get 98.5 times 19 pi divided by 12. And we get that trip is now about almost 490 feet. Not bad. Okay. And hopefully you got those same answers. All right. Now, last thing we're going to do today is we're going to focus in on sector area. Okay. And so we're going to do one more application problem involving sector area. And this is kind of a cool problem when you think about it. What I want you to do is I want you to imagine that we're talking about windshield wipers. Okay. So here's my windshield wiper arm, and here's the windshield wiper blade. Okay. I hope that makes sense. There's the blade, and this arm, beefy arm here, is swinging back and forth this way. Okay. And we're going to say that windshield wiper kind of cleans part of the windshield, and it's going to be kind of like this sector area thing. And so we'll say that the length of the entire thing all the way to here is like, I don't know, something like 34 inches. However, the length of the blade itself is only 28 inches. And the question is, what is the area that's cleaned by this windshield wiper? Okay, what is the area that's cleaned? All right. Now, the one piece of information we don't have is, well, how big of an angle is this making? I'd say, man, this thing's probably making like 120 degrees back and forth. Okay. And so what I want you to do is I want you to think about this problem. Obviously, if it's area, this is dealing with sector area, which is 1/2 r squared times theta. Okay. And so here's what I want to do. I want you to pause the video, but not for you to finish it. I want you to pause the video so that everyone just gets a start of it. Okay, so I'm going to give you like maybe like 3 minutes, but I don't want people to get done. I want you to just try to get started, and then let me kind of come in and interject and make sure you're on the right page. Okay, so we can pause the video right here, and then I'll come back in. All right, here's the important thing to realize that a lot of people don't realize. As you're looking at this, it's cleaning this section right here. Okay, and so it's missing this section down here. Okay, that section is not getting cleaned. And so to figure out just this yellow section right here, what I have to do is I got to figure out the area of the whole thing and then subtract the area that's missing. Okay, and so I got to think about the area has got to be equal to, I don't know what's going on with my pen right now. The area has got to be equal to 1/2 radius squared. So it's going to be 34 squared times theta. 120 in terms of radians is 2 pi over 3 minus that other small section down here. Well, what's the radius of that? Well, it's 6 because 34 minus 28 is 6. So that's going to be 1/2 6 squared times 2 pi over 3. And this will get you there. This will get you the right answer if you do it this way, okay? And if you say 34 squared, that's going to be 1156, and you divide that by 2 and divide that by 3. It doesn't divide by 3, but you get, well, really, I look and go, the 2 and the 2 cancels out. So I just get 34 squared, which is 1156 pi over 3, minus the 2 and the 2 cancel out, and I get 36 pi over 3. Okay, so 36 pi over 3, which would be the same thing as 12 pi. And I can subtract those two, and that's going to give me the actual area that is cleaned. Okay, and so I can say 1156 pi divided by 3 minus 12 pi. And that gives me that the area that's getting cleaned, and I could do the exact value on this one. I could kind of come up with the exact value and approximate, but I went ahead and plugged the whole thing into my calculator, and I get that the area cleaned is about, if we go to 2 sig figs, it's about 1,200 square inches. Okay, if you go to 3 sig figs, I got about 1170 square inches. If you went to 4 sig figs, what do you got? 1173 square inches. So hopefully you got the right answer on that one. All right. Man, thanks for sticking with me on this. I know that this was a lot and this was long. And so here's the deal. I'm going to give you, 5 problems to look at. Hopefully you have some time to get to work right now on them and rock out some of these so you don't have hardly any homework. But I'm on page 148, and what I'd like you to do is number 47, 48, 50, where is it? 51, 53, and 54. Okay, good luck. I'll see you Monday. Have a great weekend.